Today we're going to go over a data imputation problem. Data imputation is a very common task in data science and machine learning, where basically you could imagine that you have an Excel spreadsheet, but a lot of the cells in the spreadsheet have missing values. When you have missing values in your data, if you want to feed those data into a machine learning classifier, you're going to need to fill it with something. But what do you fill it with? That's the ultimate question of data imputation. So in this open-ended problem, we're given a data set of astronomy measurements. In this case, it's some measurements from a telescope. And as you can imagine, some measurements from telescopes can be pretty expensive to collect. And so you can imagine that a lot of them are not collected for every sample. We can take a look at our data set here, in this case the training data, and we see that there are a lot of missing values. We can also observe that the data set is not that large, maybe a couple hundred rows tops. If we want to verify that, actually let's print the shape of our data. So print xtrain.shape, and we can verify exactly, okay, so 80 rows with 5 columns each, 5 features each. So a very small data set. This will be important in choosing our imputation strategy. So what do we want to do with this data? Well, one thing, first of all, if we don't change the data, we get an accuracy of 0, a precision of 0, and a recall of 0. That's because most of the data are invalid. So we need to fill it with something so we could train our classifier with the data. The most naive approach is going to be to use a NumPy function. So let me just make sure NumPy is imported. And NumPy provides a function called nan to num, which converts all the nans, or not a number values, into a number. So let's change them into a 0. And okay, great. All the nans go to 0. We see that the accuracy jumps to 80, precision jumps to 75, and recall jumps to 90%. Awesome. So that's a very naive solution, and but one that works. Let's try a different approach. So scikit-learn comes with some imputation functionalities. So we're just going to use a simple imputer here that lets us impute by either taking the mean along each column, the median, the most frequent value, or just a constant value. So let's try taking the mean of each column. So first thing we're going to want to do is import the simple imputer. Next thing is to initialize our simple imputer object. Next, we're going to need to fit the imputer to the training data. So just fit it to xtrain. And then finally, we were going to want to call the .transform method on our training data, which will give us the imputed version of that training data. So I'm just using scikit-learn here. And okay, this method also gets 80% accuracy, 75% precision, 90% recall. But you could imagine many other more sophisticated techniques to do slightly better imputation. First of all, you could play around with trying mode, constant, most frequent, whatever you want to, I guess median, whatever other strategies you want to try. You don't have to just use the simple imputer. There are other imputers that come in scikit-learn. You could also try something where you take all the rows, maybe not for this data set, but in other data sets, take all the rows where the data is complete and use all the other values as the training data to predict what the missing column should be if you pretended that missing column that last column wasn't there, even though you do have the true value. And in doing so, you can train a classifier to predict what a missing value should be given the other values by training it on rows that have all their values. And you can imagine that would do potentially pretty well. But for that to work, you need many more rows to train a classifier well. So that's our simple data imputation problem. Useful task for data science and machine learning. Thanks for watching.